How do we create three-dimensional objects? This question is odd since most of us have drawn things like cubes before without giving it too much thought. But in mathematics, we want to describe objects with as much detail as possible. So let's take a look at two ways of creating three-dimensional objects, also known as solids. The first method is to use nets, which is what these diagrams are. Solids are going to be created when we fold the nets. For example, the left is going to create a cube, and the right is going to create a triangular pyramid. It is a good idea to familiarize yourself with some basic nets. For example, you should always be able to pair the following nets with their corresponding solids. Keep in mind that for the pyramid, the base can be any regular polygon and not just a square. The alternative way of creating a solid involves the idea of rotation. If we start with a rectangle and spin it in a circle, the space we sweep will represent a solid cylinder. If you take a triangle and do the same thing and rotate it, then you make a cone. Notice that with this technique, you will always create circular bases. Now, different parts of a solid will have different names. A vertex is a point where two or more segments meet. A segment that connects two vertices is called an edge, and a flat surface bounded by edges is a face. It is interesting to note a pattern between these three things if you look at the following pyramids. For each one of them, let's count how many faces, vertices, and edges they have. For the first pyramid, we can count 4 faces, 4 vertices, 6 edges. The second pyramid has 5 faces, 5 vertices, 8 edges. The third, 6 faces, 6 vertices, 10 edges. And the last, 7 faces, 7 vertices, and 12 edges. If I add the faces and the vertices of the first pyramid, I get 8. If I add the faces and vertices of the second pyramid, I get 10. For the third, I get 12. And for the fourth, I get 14. Notice that all I have to do is add 2 to the number of edges, and I have the same number. We express this relationship using Euler's formula and write it as the number of faces plus the number of vertices equals 2 plus the number of edges. And lastly, we will explore cross-sections. You may have seen a medical diagram where you only see a slice of something like Da Vinci's drawing where the skull is shown in profile. Or this boat that has been cut in half and you can see what it would look like if you were staring straight on. Both are examples of cross-sections. And a cross-section is an intersection of a plane and a solid. And depending on the angle of intersection, you can have multiple cross-sections. On the left, we have a static drawing where the cross-section is an oval, but notice that a cylinder can have a circle, oval, or rectangle depending on how we decide to intersect the solid. And in general, the shape of the cross-section is going to depend on how we decide to slice each solid. And with that, we end the lesson.